Welcome to The Explainer. Today, we're taking a tour of our cosmic backyard. But I gotta promise you, this is one vacation you will absolutely want to cancel. We're going to explore the extreme planetary conditions of our solar system, framing it as a darkly humorous, highly cautionary travel itinerary. If you've ever gazed up at the night sky and wondered what it would be like to actually stand on those alien worlds, well, you're about to find out exactly why Earth is the only luxury resort we'll ever need.
To really grasp the sheer lethality of space, we're going to break our solar system down into a few distinct hazard zones. We'll start with a planetary survival guide, visit the hostile inner planets, move on to the lethal gas giants, and finally, brave the crushing ice giants.
Okay, let's dive into this. Part 1, the Planetary Survival Guide, why you should definitely stay home.
You know, when we think about the dangers of space travel, we usually just worry about running out of oxygen, right? But the reality is that space relies on extreme sensory horrors. Think corrosive acid and literally flesh-melting radiation to actively repel visitors. You might think a super advanced spacesuit could protect you, but the extremes we're about to look at far exceed even the most cutting-edge NASA engineering. Honestly, an indestructible spaceship is just the bare minimum requirement to even get close.
Moving right along to Part 2, the hostile inner planets, Mercury, Venus, and Mars.
Because these rocky neighbors are relatively close by, you might kind of think they're welcoming. Yeah, don't let that fool you. Let's compare them, starting with Mercury. So Mercury has no real atmosphere, just an incredibly thin exosphere. That means near zero surface pressure and no real weather to speak of. But it gets almost 7 times the solar irradiance that Earth receives. And because there's almost zero air resistance, slowing down your spaceship would be incredibly difficult. You're looking at a high-speed crash landing onto a heavily cratered surface as, well, extremely likely.
But let's say you did manage to land safely. You'd immediately face a massive temperature problem. Mercury's daytime reaches a blistering 430 degrees Celsius, while the night plummets to a freezing minus 180 degrees. To put that into perspective, the absolute latest NASA spacesuits can only handle temperatures between 121 and minus 157 degrees. And since a single day on Mercury lasts about half an Earth year, you can't exactly just wait it out in the shade. Your only slim hope of survival is landing in the Terminator Zone. That's this narrow, shifting strip of twilight right between the day and night sides where temperatures are, well, somewhat moderate.
Now, let's shift over to Venus, which is just 40 million kilometers away. That's about a 4-month journey. But honestly, you'll want to turn the ship right around. The surface pressure on Venus is 92 bars. That is 92 times the atmospheric pressure at sea level here on Earth. That kind of intense pressure is enough to instantly crush a military submarine. Even if your suit somehow held up, the air is so densely packed with carbon dioxide that just moving your arms and legs would feel like wading through wet concrete, all while roasting in 450 degrees Celsius heat.
And getting down to that surface? An absolute nightmare in itself. Venus's atmosphere is incredibly thick. So thick that only about 10% of the sun's light ever reaches the ground. It's a very dark, incredibly oppressive world. As you descend, you'd pass through these really striking, beautiful yellow clouds, but do not be charmed by them. Those clouds are made of highly corrosive sulfuric acid. If your pressurized suit were to breach, and let's be real, it absolutely would under 92 bars of pressure, that acid would destroy your lungs in a matter of seconds. Next up is Mars, our most famous neighbor. Guys, this is the ultimate rug pull of the solar system. At first glance, Mars actually seems like the most habitable option. In certain places near the equator, daytime temperatures can reach a wonderfully balmy 20 degrees Celsius. It kind of gives you this false hope, like, hey, I could just step outside in a light jacket.
But then, the sun goes down. We have to snap back to brutal reality here. At night, Mars drops to a bone-chilling minus 130 degrees Celsius. It will violently pelt you with sudden dust storms, with winds tearing across the surface at 100 kilometers per hour. And because its carbon dioxide atmosphere is so incredibly thin, you are constantly bombarded by an average of 24 to 30 rads of radiation. That is 40 to 50 times the radiation exposure you'd get on Earth. So without a heavily insulated, perfectly airtight life support system, Mars will just quietly, efficiently freeze and irradiate you.
Now, what's really interesting is how things change as we move further out. Part 3, the lethal gas giants, Jupiter and Saturn.
Unlike the rocky inner planets, these massive gas giants don't even let you land before they start tearing you apart. Jupiter, for example, violently pulls you in with 2.4 times Earth's gravity. Let's walk through this terrifying descent, shall we? Step 1, you plunge into minus 150 degrees Celsius clouds of frozen ammonia, getting completely battered by 482 km/h winds. Fun fact, NASA's Galileo probe did exactly this back in 1995, and it only survived about 150 kilometers down into that top layer before the immense pressure and crushing darkness just totally took over. If you somehow kept falling, you'd hit Step 2, an ocean of supercritical fluid. Then Step 3, dense, liquid metallic hydrogen that would physically trap you. And finally, Step 4, you'd slam into the core, blazing at 24,000 degrees Celsius.
I want to elaborate on Step 2 for a second, because it's fascinatingly grim. Deep inside Jupiter, the pressure forces gases into what's called a supercritical fluid. This is a truly bizarre state of matter that acts as neither a true liquid nor a true gas. So you wouldn't be falling anymore, you'd actually be swimming or floating through this incredibly dense alien substance. And keep in mind, you're doing all of this while being exposed to radiation so intense that Jupiter's magnetic field could literally kill you from 300,000 kilometers away. That's before you even touch the atmosphere.
It's honestly difficult to even conceptualize the forces at work here. By the time you get anywhere near Jupiter's center, the pressure is estimated to be 100 million times Earth's atmospheric pressure. 100 million. And that core we just mentioned? It is roughly 4.5 times hotter than the surface of our own sun. Just mind-boggling.
Then there's Saturn, which is essentially an impossible gauntlet. Just approaching the planet requires you to dodge 146 orbiting moons and vast sweeping rings made of ice pellets, comets, and asteroids. If you survive that little obstacle course, you hit the atmosphere. You'll see these beautiful red and purple auras right before you're shredded by 1,800 km/h hurricane winds. Oh, and if you try entering through the North Pole, you'll encounter a swirling ammonia storm so massive you could drop 2 entire Earths inside it. You'd plunge past clouds at minus 250 degrees Celsius, falling deeper and deeper until the pressure, which gets to around 1,000 times that of Earth, forces the gases into a liquid state. Eventually, you'd hit a molten rocky core 10 times the size of Earth, baking at 11,700 degrees Celsius.
Let's move to the outer edges and see how this builds. What happens when you mix extreme planetary pressure with atmospheric methane on the absolute farthest edge of our solar system? Well, the bizarre weather phenomena waiting for us out there are truly mind-bending. Which brings us to part 4, the crushing ice giants, Uranus and Neptune.
We have finally arrived at the incredibly distant, impossibly dark ice giants. Uranus, for instance, spins completely on its side, whipping up absolutely chaotic weather in rapid 17-hour days. But the crucial point here is understanding what an ice giant actually is. It's scientific jargon and it can be a little misleading. Being an ice giant doesn't mean the planet is just a giant, smooth ball of ice, like some endless skating rink. No, it means the planet is mostly composed of elements heavier than hydrogen and helium. So if you tried to visit, you aren't landing on ice. You are sinking into a minus 200 degrees Celsius atmosphere made of toxic gas, where you're just violently pelted by high-speed ice pellets.
Let's compare these two icy twins. Uranus boasts the title of the coldest planet in the solar system, dropping below minus 200 degrees Celsius. Then we have Neptune. Neptune is 30 times farther from the sun than Earth is, making it incredibly pitch black. Yet despite being freezing on the outside, Neptune hides a core that is 7,000 degrees Celsius, which is hotter than the surface of the sun. Both of these giants feature atmospheric pressures about 100 times greater than Earth's, but Neptune pairs that with supersonic winds that would just obliterate any known spacecraft.
And this brilliantly illustrates the answer to our previous question about methane and high pressure. Deep within the atmospheres of both Uranus and Neptune, the immense pressure actually breaks down the methane gas, crystallizing the carbon. This means that as you are being crushed by 100 times Earth's pressure and whipped around by supersonic 900 km/h winds, you would also be pelted by a literal rainstorm of solid diamonds. It's a remarkably beautiful concept, happening in an environment that is perfectly designed to instantly destroy you. Which really leaves us with a staggering realization. If every single planet in our solar system, from the sun-scorched terminator zone of Mercury to the crushing diamond rain of Neptune, is uniquely equipped to crush, freeze, dissolve, or irradiate us, how will humanity ever bridge the gap to become an interplanetary species? The immense technological leaps required just to survive a brief visit to our cosmic neighbors are almost beyond comprehension. It kind of makes you look at the gentle breeze and breathable air right outside your window with a whole new level of appreciation, doesn't it? Thank you so much for joining me on this explainer. Keep learning, keep wondering, and maybe, just stay on Earth for now.